So far in the course, you've added working with 2 different types of language models to your NLP toolkit. There are many different language models out there, and so this section of the course, I want to introduce you to another model called XLNET. XLNET is a large language model developed by Google AI in collaboration with universities and other institutions in 2019. It comes in 2 sizes, XLNet Base, which contains 110 million parameters, and XLNet Large, with 340 million parameters. Unlike BERT, which consists of encoder layers stacked on top of one another, XLNet is a decoder-only architecture. We stack several layers of decoders to create the XLNet architecture, 12 layers for XLNet Base, and 24 layers for XLNet Large. The key innovation of XLNet is that it overcomes some of the limitations of previous models in terms of how it processes text to get a deeper understanding of context. One of the fundamental differences between XLNet and earlier models like BERT is the way they handle context. In traditional autoregressive language models like GPT, the training objective is to predict the next word in a sequence given the previous words, typically moving from left to right. In contrast, BERT uses a masked language model objective where some words in a sentence are randomly masked, and the model's task is to predict the masked words based on the surrounding context. XLNet takes a different approach. During pre-training, XLNet can consider all words in the context, not just the words to the left and right of the target word. XLNet samples different permutations of the input data. This means that it considers different ways to mask out and predict words in the sequence. By doing this, it learns to predict the probability of each word given the entire context it has learned from the whole text. This leads to improved contextual understanding. The key advantage of permutation-based training in XLNet is that it can capture bidirectional context effectively. In each training instance, it's as if the model is trying to predict each word in the sequence by considering all the other words around it, not just those to the left and the right. This helps the model understand the relationships between words in a more comprehensive manner. XLNet makes an independent assumption when computing the probability of a word. It assumes that the probability of a word being generated is conditionally independent on the other words in the sequence, given the entire context. To put it simply, this just means that the model doesn't rely on the order of words to predict a particular word, but it considers the entire context, so it looks at all the words in the text rather than just the order and the words either side of the current token. The permutation-based training in XLNet overcomes the limitations of a purely autoregressive model, such as GPT. While autoregressive models generate words sequentially, they may not capture long-range dependencies or bidirectional context effectively. In contrast, XLNet maintains the autoregressive property of predicting words one at a time, but it considers the entire sequence during its prediction. XLNet achieved state-of-the-art results on a variety of benchmark NLP tasks, including question answering, text classification, and language modeling. Its ability to model bidirectional context effectively and capture long-range dependencies in text contributed to its success. In the next few lessons, we'll learn how to fine-tune an XLNet model for our own specific tasks. This is a powerful skill and will provide you with the knowledge of how we can use Hugging Face to fine-tune a large language model for yourself.